Here are the answers for lesson 9-3. There are some word problems. In the word problems, you're going to be asked to find two unknown values. Because there are two unknowns, we can use two different variables to represent them. Then you'll be given information about relationships involving the two unknown numbers. From those sentences, we can create equations. The result will be two equations that have two variables, and that's called a system, which we can solve with methods that we've been recently practicing. Now, as you look at these problems, you might remember from earlier in the year that you did the same problems, but at that time, we hadn't yet learned about systems of equations with two variables. We only solved equations with one variable. So at the time that we solved these earlier, our method was to use only one variable and then represent the other unknown quantity using that first variable. Now that we know about systems, we have another method that we can use to solve them. Now the problem-solving plan is on screen. Select two appropriate variables. Usually you pick letters of the alphabet that correspond to something in the story. Then write two different equations involving the variables. After you've written the equations, solve the system, and then check the answer against the story problem to make sure that it makes sense. Our first one is number 11. The sum of two numbers is 100. This is describing a relationship between two numbers. Now there's another sentence. 5 times the smaller number is 8 more than the larger number. This also describes a relationship. Now, what are we asked? Find the numbers. We don't know what they are, and there's two of them. So our variable choices, let x be one of the numbers, and y be the other number. Now, you don't have to choose the letters X and Y. You could choose A and B or M and N, whatever you want. Now that we know that we're going to use these two variables, X and Y, we want to create two equations. They both need to have X and Y in them. And for this, we'll use the sentences that describe the relationships. So our first relationship, the word sum means you're adding. We're adding the two numbers, and the word is equals. When you add the two numbers, it equals to 100. So x plus y is equal to 100. Now the next sentence gives us another relationship. 5 times the smaller could be written as 5x if we're saying that x is the smaller number. Now the word is, that's an equals. And then 8 more than the larger would be y plus 8. These two equations written together, one on top of the other, is called a system. Now we're ready to solve. One of the methods that we've learned about is graphing method, but graphing method is perhaps not so great here because 100 is a very large number. Another method that we know about is substitution method. In substitution method, you need to get one of the variables alone in one of the equations. I'm going to work with the first equation and subtract x from both sides, getting y equals 100, take away x. Then substitute that expression in place of the letter y in the other equation. So we have 5x equals 100 minus x, and then plus 8. Add x to both sides, creating 6x. Combine 100 plus 8, creating 108. Now divide both sides by 6, and the result is 18. Now substitute again. Take the 18 and use it in place of the letter x. So we have y is equal to 100 minus 18. Therefore, y is equal to 82. Now, in the earlier chapter where we were practicing substitution method, we would write our answer as an ordered pair. That's not what you want to do here. We're doing a story problem, so we want to write our answer in a way that answers the question. We were asked to find the two numbers. So the numbers are 18 and 82. Now number 13. Lisa and Beverly had just $5 to spend for an after-school snack. They could have bought 2 hamburgers and 1 carton of milk with their $5, getting no change back. So the 2 hamburgers and 1 carton adds up to exactly $5. Or they could have bought 1 hamburger and 2 cartons of milk, but got 40 cents back. That means the cost of the hamburger plus the cost of the 2 cartons plus 40 cents is equal to 5. Now, what's the question? How much does a carton of milk cost? There are 2 unknown quantities. The cost of the milk is unknown and the cost of the hamburgers is unknown. Let's choose variables. Let x be the cost of the hamburgers, or cost of a hamburger, and y be the cost of the carton of milk. Now that we know we're going to use 2 variables, x and y, we need to create 2 equations that involve both of these letters. 2 hamburgers would cost 2 times x. If x is the cost of 1 hamburger, then you could multiply that by 2 to be the cost of 2 hamburgers. Plus, 1 carton of milk costs y. And we're told they get no change back, so this must have added up to exactly the $5 that they had. Now the second relationship, 1 hamburger, or 1 times x, just x, plus 2 cartons of milk, 2 times y, plus 40 cents, adds up to $5. Alternatively, you might have written this as x plus 2y is equal to $4.60. That would have been the same idea. These 2 equations are the system, and now we want to solve them. Now, I'm not going to use graphing method. I want to use an algebra method, and I'm going to go with substitution method. That's the one we know about so far. And take the first equation and solve it for y by subtracting 2x. Then take that expression and substitute it in place of the letter y. So it's x plus 2 parentheses. Now substitute in 5 minus 2x. And then I have the plus 40 cents is equal to $5. Now some distributive property here. This is x plus 10 minus 4x. And I'm going to right now subtract the 40 cents from both sides, getting 4.60 on the right. Now combine like terms. 1x minus 4x is negative 3x. And now I'm going to subtract 10 from both sides, getting negative 5.40. Next, divide both sides by negative 3. And the result is 1.8. What was the letter X representing? It was the cost of a hamburger. Well, what did the question ask us to figure out? The cost of the carton of milk, which is being represented with the letter Y. We don't yet know the letter y. We've only figured out the letter x. So take the 1.8 and substitute it into our equation that the letter y is alone. So y equals 5 minus 2 times 1.8. This is equal to 5 minus 3.6, which is equal to 1.4. Now we know the answer for y, and it was the letter y that was representing the cost of a carton of milk. Now, I don't want to write my answer as an ordered pair. That's not what this is about. We just want to know, what is the cost of the milk? That is $1.40. Now, number 15. Marty Lister invested $9,000 in stocks and bonds. So he put some of the money in stocks and some of the money in bonds. And together, it adds up to $9,000. That's showing a relationship between the unknown amount in stocks and the unknown amount in bonds. The next sentence says the stocks paid 5% interest and the bonds paid 8% interest, giving an annual income of $525. That's giving us another relationship, a relationship about the interest earned on these investments and how it's going to add up to $525. Now the question, how much money did he invest in bonds? All right, there are two unknowns. How much was invested in stocks and how much was invested in bonds? So I'm going to pick two variables. Let X be the amount in stocks and Y be the amount in bonds. Now, I certainly didn't have to pick X and Y. In fact, it probably would make sense to use S for stocks and B for bonds. But I'm going to use X and Y. Now, I want to create two equations, and they both need to involve X and Y. So our first relationship was how the amount invested in both is going to add up to 9,000. As soon as I write X, but I think what it means, I've written the amount in stocks. Now plus, and when I write Y and think about what it means, that's the amount in bonds. Instead of just saying X plus Y, if I think about the meaning, I've written the amount in stocks plus the amount in bonds is equal to, and I can put 5,000. Now the second sentence, the stocks pay 5% interest. Here's what that means. I can take the decimal version of 5%, which is 0.05, and multiply it by the amount of money put into stocks. And when you multiply those together, it creates something called the interest earned on the stocks. Now add. The next percent is 8%. What is that as a decimal? That's 0.08. And that 8% is on the bonds. So I'm going to put the variable Y next to it. And that's equal to the total amount of interest made, which is $525. So that second equation in symbols looks like this, but think about its actual meaning. This right here is the interest earned on stocks plus the interest earned on bonds adds up to $525. Here is our system. Now we want to solve this. I'm going to go with substitution method again. Take the first equation and solve it for one of its variables. Now, what's a good variable to solve for, X or Y? They both have a 1 in front, so it's going to take an equal amount of effort to get the letter alone. What did the question ask us? It asked us how much in bonds. Well, which variable is that? That's the letter Y. So should I get the X alone right now or the Y alone? What's the better thing to do? You think about that. I'm going to choose to get the letter X alone. So X equals 5,000 minus Y. and take the 5,000 minus y and substitute it in place of the variable x in the other equation. So it makes 0.05 parentheses. Now fill in the 5,000 minus y, and then plus 0.08y equals to 525. Do you understand why I chose to get the letter x alone in the first equation, even though I wanted to get a number for y? By doing that, I've created an equation that only has the letter y in it. So when I solve this equation, I'm going to right now have y equals a number. And that number will be the answer that I'm looking for. So that saves me time. Let's do some distributive property. We're going to have to multiply right here. This makes 250 minus 0.05y. And then there's the plus 0.08y, and the equals 525. I'm going to subtract the 250 to the other side. 525 subtract 250 makes 275. And I will combine like terms, this y term and this y term, combining together makes 0.03y. Now divide both sides by 0.03. And the result is 9166.67 if you round to the hundredths position. What was the letter y representing? It was the amount in bonds. What did the question ask for? It asked for the amount in bonds. So there is no need to take this number and substitute it and find the answer for x. I don't need to know what x is. I only need to know the amount in bonds. So to write my answer, I'm going to include a dollar sign because this is about money, and then give the number so that it looks like money. Here it is. Now number 17. A car and a bike set out at noon from the same point headed in the same direction. At 1 o'clock, the car is 60 kilometers ahead of the bike. What are we asked for? Find how fast each travels. And then we're given another relationship. The car travels 4 times as fast as the bike. Okay, we need variables, but what are the variables representing? What are the unknown things we're asked for? We're asked how fast they go. So our variables need to represent how fast they go. They need to represent the speed of each thing. So let x be the speed of the car, and y will be the speed of the bike. Now you didn't have to use x and y. In fact, it makes more sense probably to use c and b. Okay, now I want to create 2 equations, and I need to make the equations from the information given to me. I'm told that the car and the bike start at noon. That's probably important. I'm told that they start from the same point and that they go in the same direction. Now it says at 1 o'clock. So how much time's gone by? 1 hour. Something has happened in 1 hour. The car is 60 kilometers ahead of the bike. How can I represent that information using my variables? Well, one thing that is important to remember is that distance is equal to speed times time. This is a math formula from earlier in the year. The distance that something travels is equal to its rate of speed multiplied by the time that it travels. I think with this math formula, it'll help us make some equations using the information. Let's write an equation involving the distance that the 2 things travel. Distance is equal to rate of speed times time, and the time is 1 hour. So the distance that the car travels is its rate of speed, x, times 1 hour. Well, x times 1 is just x. And that distance is equal to 60 more than the distance the bike traveled. Well, the bike's distance is its rate of speed times the time that it travels. The bike's rate of speed is y, and it traveled for 1 hour. Y times 1 is just y. This equation shows the relationship between the distances that the two things traveled. Now, let's use the very last sentence to get another relationship. It says the car travels 4 times as fast as the bike. So the car's speed is or equals 4 times the speed of the bike. Here is our system. Now observe in this system how the first equation has the letter x alone. In fact, the second equation also has the letter x alone. So we can substitute this expression in place of the letter x, creating 60 plus y is equal to 4y. Subtract y from both sides, get 3y. Now divide by 3 on both sides. Y is equal to 20. Okay, what is the letter y? It's the bike speed. So we figured out how fast the bike was going. Do we also need to figure out the car speed? Yes. So we take the number 20 and substitute it into that first equation. We get x equals 60 plus 20, which is equal to 80. Now we know the speed of the car. Now when I write the answer, I want to write it in a way that answers the question. So I'm going to say car and give it speed, kilometers per hour. And then I'll write bike and give it speed, 20 kilometers per hour.